Hello everyone, I am Vidhyalakshmi from Vidhyalakshmi Metric Higher Secondary School. Today we are going to learn thermodynamics. Do you know what is meant by thermodynamics? Let's see the definition for thermodynamics. The term thermodynamics means flow of heat. It is derived from the Greek. Thermos means heat and dynamics means flow. Let us see some examples for thermodynamics. Burning of fuel to produce heat energy, flow of electrons to the circuit to produce electrical energy. Move on to the next topic, zeroth law of thermodynamics. What is meant by zeroth law of thermodynamics? It states if two systems are separately in thermal equilibrium with the third one, then they tend to be in the thermal equilibrium with themselves. If A is in equilibrium with B and C, then B and C are said to be in thermal equilibrium with themselves. Let us see an example for zeroth law of thermodynamics. When you measure your room temperature and you got 27 degrees Celsius, according to zeroth law of thermodynamics, you can assume that your room and your things in your room, pillows, cabinet and couch have the same temperature of 27 degrees Celsius. Move on to the next topic, first law of thermodynamics. It is also known as law of conservation of energy. It states that energy can neither be created nor be destroyed, but not converted from one form to another. The mathematical statement for first law of thermodynamics is delta U is equal to Q plus W. Here delta U is change in internal energy, Q is the amount of heat supplied to the system and W is the work done on the system. Let us see mathematical statement of first law. The first law of thermodynamics is delta U is equal to Q plus W. In case 1, for cyclic process, the isothermal expansion of the gas is delta U is equal to 0. Substitute this in equation 1, then you get Q is equal to minus W. We can say that amount of heat absorbed by the system is equal to work done by the system. In case 2, for an isochoric process, there is no change in volume, that is delta V is equal to 0. So, delta U is equal to Q plus W, that we know already. So, here we can write W as minus P delta V, substitute this minus P delta V in this equation. So, now we know that delta V is equal to 0, so delta U is equal to Q. We can say that during an isochoric process, the amount of heat supplied to the system is converted to internal energy. In case 3, for an adiabatic process, there is no changes in heat, that is Q is equal to 0. We know the first law of thermodynamics, so you substitute this Q is equal to 0 in delta U is equal to Q plus W, then you got delta U is equal to W. In other words, we can say decrease in internal energy is equal to work done by the system on its surroundings. In case 4, for an isobaric process, there is no change in pressure, that is P is constant. So, we know that delta U is equal to Q plus W. We already seen in the case 2, we can write W as P delta V. So, substitute this in this equation, delta U is equal to Q minus P delta V. Here P is equal to constant. Let us move on to the next topic, zeroth law of second law of thermodynamics. What is meant by second law of thermodynamics? It helps us to predict whether the reaction is feasible or not, that is the reaction is possible or not, and also tells the direction of flow of heat. To predict the spontaneity of a process, a new thermodynamic quantity was introduced, namely entropy. What is meant by entropy? It is a measurement of randomness or disorderliness of the system. Let us see an example for second law of thermodynamics. A glass of hot water over time loses its heat energy to the surroundings and becomes cold. Move on to the last topic, third law of thermodynamics. What is meant by third law of thermodynamics? It can be stated that it is impossible to lower the temperature of an object to absolute 0 in a finite number of steps. Or we can say at absolute 0, the entropy of a perfectly crystalline material is 0. Example, at absolute 0, the molecules are stop moving and vibrating at all. At low entropy, the molecules are stop moving, and at high entropy, the molecules are start vibrating. I would like to thank Stalin sir, Department of Chemistry, for his support throughout this process. Thank you for listening this presentation. Thank you.